So we're going to talk about things that will bring things sort of full circle this year. So you are good with solving square root equations. And I'm going to make up a square root equation. And I've only made up half of it. But clearly if I put something like a 5 here, things are going to work out well. We're going to square both sides. We're going to get, on the left-hand side, just x plus 20, on the right-hand side, 25. We're going to solve for x, we're going to get 5, and everything is true, right? 5 plus 20, if we plug it back into the original equation, would give us the square root of 25, which would give us 5, which is exactly what we started with. Everything's good. However, had I done this, right away you would know something's up. You can't take the square root of some number, principal square root, and get negative 5. But if you were going to just follow the procedures, you'd get exactly the same answer. And this is what we called an extraneous root, because the square root of 25 is not negative 5. It is true, negative 5 squared is 25, but here somebody is asking for the principal root. And we'll talk about this in a few days too. But this is an extraneous root. It's the only thing that quote-unquote works, but it doesn't work in the original, so we have no solution. Okay, so here's what we're really going to do today. The same thing, except I'm going to put an x here. Now, the problem with x is that we don't know what x is. Whatever x is here, that remains to be seen when we finally solve the equation. So I do have to keep in mind that possibility that maybe x is negative, maybe x is positive. But I'm still going to follow my same routine. I'm going to square both sides. On the left-hand side again, squaring cancels out the square root. So we're just left with x plus 20 again. On the right-hand side, we have x squared, and suddenly we're back to looking at quadratic equations, right? This is a quadratic equation. I haven't talked about them in a long time. But remember, for a quadratic equation, we're going to use the zero product property. So I want to set this equal to 0, so I'm going to subtract x from both sides. I'm going to subtract 20. So on the left-hand side, I have 0, right? They cancel out. And on the right-hand side, I don't have any like terms. So I just have x squared minus x minus 20. We're going to factor that into two binomials. I can't take anything out of each term. And the factors of 20 that are going to work are negative 5 and positive 4. And you can go back and check that, which means either x minus 5 is 0 or x plus 4 is 0 by the zero product property. If we're multiplying this guy by this guy and getting 0, one of those things has got to be 0, meaning x is 5 or x is negative 4. Now, if we go back to our original problem, I know that this has got to be a positive number. So x is equal to negative 4. This is an extraneous root. So our only solution here that's going to work in the original is 5. And again, an extraneous root means that both of these, in fact, are solutions to the quadratic, but not to the original. So the word to the wise is, when you have a quadratic equation or when you solve any sort of square root equation, always go back and check in the original. If I plugged in negative 4, that would give me square root of 16 is negative 4. And again, it's true, negative 4 squared is 16. But here somebody's asking for the positive root.